Hello, my name is Roland Reyer. I'm a technical specialist at Autodesk Media Entertainment in Europe. I'd like to present my latest project that I call Procedural Polygon Generation in Bifrost. It is heavily inspired by a presentation that Maxime Jeanmougin from Platinum Games gave at the GDC 2022. In the presentation, he shows a system that can be used to procedurally create buildings. According to him, this system is based on the work of Akira Saito, who described the concept back in 2019. My system works similar to the one that Maxime described. Polygons are split and extruded. The newly created polygons are assigned face tags, which are collections of faces to which further operations can be applied. For the extrude function, I used the ingenious notes written by the user HeyDoubleU from the Discord group Bifrost Addicts. For all references, links can be found in the description of the video. Here we see a sample scene that is included in the package. I created this apartment front with balcony for testing purposes, as well as this building. The Bifrost graph may give you some hints on how to create certain things. In addition, the Bifrost graph contains a collection of the most important nodes. Unfortunately, the nodes are not documented yet. This scene here will also be included in the package. This building was built by Maxime Jeanmougin to illustrate the procedural polygon functions for his talk. I liked it so much that I rebuilt it completely. So let's now jump into a little tutorial to understand how this whole process works. Okay, let's start with a very simple example to show you some principle. Also, at the very beginning, there are some obstacles to overcome to actually start with the whole process. I have a very simple object here, a polygon plane that I turned down the subdivisions to 1 so that we end with having just one polygon here in the scene. And I've already connected this polygon shape to the output in Bifrost. So what we see here is actually the Bifrost object instead of the real object, which the polygon plane here, which is hidden. I start by adding a node here in Bifrost, a so-called multicut node. I call it PPG multicut. And I alt drag and drop it onto the wire here and connect it into the mesh. And you see that nothing happens. Unfortunately, at the beginning, there is one extra step necessary. The whole suite of nodes here works with so-called face tags. Face tags are collections of faces with a name, and you can use this text field here to specify which face tag or a number of face tags you want to work on. So in this case, it would be everything. You can use wildcards here, but since there is no single face tag in the scene, it would select nothing. Fortunately, there is an invert button so that I can invert it, and then I see my subdivisions here. And before I even go on here, resize this a little bit. Before I even go on here, I want to make sure that I see a little bit better what I'm doing here. So I want to include a node called assign random colors. And this assign random colors does exactly what the name says. It assigns random colors to the face tags. So here you see we have two different face tags, this orange-brown one and the blue one. And this assign random colors simply takes the names of these tags and picks a color from a large list of random colors here. Another node that is super helpful here is called display face tags, for which you have to have the print pack installed, print pack 2.5. So that's included in the package. You can use that here. So when I do that, you see that some names appear here, inner and outer. And when we go back to the multicut node, we see down here under tags, we have a tag called outer, which is obviously the orange part of the whole thing, and inner, which is the blue part. And both have an underscore because they have their inherit source tag flag on, which means that it tries to put the name of the parent tag. So if that was this one polygon would have a tag already, then this parent tag would be in front of this. This makes it easier to get unique names. Otherwise, you would have to always think of a new name for these inner and outer tags. So that's the basic principle. Before we go on with these settings here, let's first go back to our polygon plane and scale the polygon plane. So you see when I make it wider, it starts subdividing itself. And that is because it tries to maintain these sizes here, the inner size and the outer size. And the inner size, we can see that here, the inner size is flexible in this case, so it can compensate a little bit until there is more space for a new subdivision, right? So it tries to maintain this ratio. Outer size is 1 unit and inner size is 2 units. And the inner size is flexible here. I can also set the outer size to be flexible to specify exact sizes for this inner strip here. This one here, the mode, describes what happens on the ends of the whole thing. Double side or half side means that the end strips are only half the size. Start and end do respective things, and there's even a no end side which turns the whole thing around. So a name about the subdivision. This is all easy if it's a rectangular polygon. And it's an upright rectangular polygon, because then I don't have to choose which side I want to subdivide. Simple idea here, when we unhide the polygon and pick one of these facets here, and I move it in this direction, you see that it keeps subdividing. And then when I pick this one here and move it in the same direction, it does not subdivide. So it's not subdividing this edge, obviously, or it's not measuring this edge, it's measuring the one down here, and decides if or not it would subdivide or make a new subdivision. And you pick these edges here with this section here, the cutting direction. At the currently it's set to cutting vector, which means there's a vector from the center pointing downwards, and then, you know, the edge that it finds there, that's the one that will be subdivided. So if I rotate this polygon, rotate the polygon, and you see, boom, there's a certain point. Now this is the one where the cutting vector points at, and it will be subdivided. When I rotate back, boom, then suddenly the other one is the one that gets subdivided. This edge is now subdivided. I can swap the direction and make a +1 and then subdivide this one here. Whoops. Now this one will be subdivided. We can see that when I make this one longer, I get more subdivisions. And here not. Okay. And when I make opposite edge, like this one here, then suddenly this edge will be subdivided and this one will not, right? So that's an important part of the whole process, to be able to choose the edges. Aside from direction vector, you have the longest edge, the shortest edge, or simply a point index. So you would display the polygon points and say, okay, starting from point 0, this edge would be it. Starting from point 1, this edge would be the one that gets subdivided. So that is important when you look at something and it's not clear how to select a certain edge, you will have to go into this thing here. So we go back to the default subdivision, and now I want to do another subdivision. So what I want to do now is to take this blue strip here and make subdivisions only on the blue strip, and that works like this. PPG multicut. And I drag it into this thing here, and you see that it cuts in the same direction because the direction vector is the same. So I swap the direction to be, horizontal cuts, but now it cuts everything. Yeah, clear. Here in the tag expression section, we have the wildcard, so it picks all the tags that it has before and cuts them all. This is too much. I don't need all of these polygons here. So let me turn it off again and have a look. Yeah, so this is the tag that I want to subdivide. It's called _inner. And now when I turn it back on, you see that only this _inner strip is getting subdivided. And we get the names here, like inner_inner from this one here, and inner_outer from the other tag. I could also turn this off and say the inner one is my window, and the outer one is maybe just the wall or so, parapet, however you want to call it. So this is not so bad. I can go on with my process, and now I want to take these windows and extrude them a little bit into the building. So let's pick a PPG extrude node. Currently it doesn't extrude anything because we want to pick the window here, not selected faces. Window, so it's not clear if I should, always have the wildcard in there, or maybe very specific expressions so that it doesn't extrude by default. So by default it extrudes outward, and this blackish shade here on the polygons means that the normals are not good. So I'll zoom out a little bit, make more space, and include another node of soften harden to fix the normals here. Mesh to outer mesh. Soften harden fixes it. And then I can go back to the extrude. And this is easy, you know, here in geometry we have a distance and an offset. Offset is the scaling of the whole thing. And this one here, the distance is inside. Oh, what we see here is now our polygon plane. So I have to pick this one here and hide it. And now I can see, you know, how my extrusion would look like. So we can say these new extrude faces here are the new windows. And this is the wind sides or something like that. Okay. We can make the tags a little bit smaller, becomes messy after a while if they are too big. So what else? So now I want to go and extrude the outer ones to be, you know, some sort of columns, outstanding columns on our building. So that is another extrude node here. So let's pick the wire before PPG extrude. And we'll put it in automatically. And then we pick the underscore outer as an extrude. Yeah, that's it already. So maybe less of a distance here and different names. So the faces are column and the sides are column sides. Okay, and that already looks a little bit like a building. What the real good thing is now, when we go back to this polygon plane here that we have at the beginning, and do the scaling, you see that it keeps subdividing itself, even with all the extrudes, and so it subdivides itself. And I can also adjust all the sizes afterwards. So columns a little bit larger or smaller, you know, the window sizes, the column of these window strips, everything is still available for modification. So it starts looking like a building, maybe less of this one here. And, you know, one last step that I would like to do, maybe make it smaller again, is that I want to create a little balcony in this thing. So in my scene, I already have a very simple balcony object here that I want to place where these windows are. So unfortunately, this balcony object is not the same size as the window, so we have to stretch it a little bit, but that happens automatically. So I bring it into my scene. And before I create this instance node that will do that, I create a node called select random faces. And it does exactly what it's supposed to do. It selects random faces and assigns a new face tag. In this case, random. But I want to select random windows here. So let's go back to the window. And we want to turn off the inherit. So the name is simply window. And here I say amongst the windows, I want to select some random faces and assign a new tag. So now I have some of the windows are called random. And that would be the thing that I feed into my instancer here. So the node is called PPG instance. No big deal. So the instancer here takes this source tag, in this case random. Okay, and deletes the windows because there is no instance in there. So I've not yet connected the instance object. You can connect a bunch of objects and then you have the choice to, you know, choose how they are distributed. You can even feed in IDs for the different windows to make clear. So now these balconies are have one face tag, so they turn into one color because of this name, this inst.obj name. All the face tags on all the instances may become a little bit messy because instances are also there for complex object. So what I can do here is to, in the display face tag node, I can say, I want to see all the face tags except the ones that start with inst underscore, for example, and then wildcard. So these ones are not labeled. I don't need to label to see that this is a balcony, obviously. So the rest is, of course, you know, you need these tags to as an orientation. Otherwise, you are lost very quickly in this whole mass of polygons that you can create easily. Look how easy I can now make the front of a large building out of this, and maybe turn off the face tags now to better see what the building would look like. All right, so this starts to look like a building. And of course, the face colors, I can turn them off as well. So here's my building. Not so bad for a few minutes of work. Okay, so of course we have to talk about all these other nodes that are in there, but this is the basic principle of, subdividing and extruding and instancing these polygons here.